A block of mass 2 kg is placed on a trolley of mass 5 kg moving horizontally. A force of 8 Newton is applied to the block which slides on the surface of the trolley. The frictional force between the trolley and the ground is 0. The trolley accelerates at the rate of 1 meter per second squared. What is the coefficient of dynamic friction between the block and the trolley? He wants us to find the coefficient of dynamic friction, which is mu d. If we look into the physics data booklet under topic 8.2, we can see that the first two equations are about friction. The first equation is about static friction, while the second one is about dynamic friction. Any object that's in motion will have dynamic friction. Before we can solve for mu d, we need to make sure that we have the other two parameters in this case, which is the friction and the normal reaction force. If we look back into the diagram, we know that the normal reaction force on the block will look like this. The block is not moving up and down. We know that the normal reaction force on the block must be equal to the weight of the block itself. So we can straight away calculate this value. So we have the mass of the block, which is 2 kg times by gravity 9.8, and that will give us 19.6 Newton. Since the force of 8 Newton is acting on the block in this direction, that means the friction on the trolley must be acting in this direction. This means that the trolley is accelerating in this direction. Now, according to Newton's second law, F is equal to ma. And we clearly know that we have to substitute F with the actual force of forces that is acting on the trolley. In this case, the only force that is acting on the trolley is the friction. So therefore, we are going to substitute friction into this equation. So friction is equal to ma, and m is mass of the trolley, 5 kg, and the acceleration is 1, so we have 5 Newton. So now that we have the value for the friction, which is 5 Newton, we can substitute into this equation now. So we have mu d equivalent to 5 Newton divided by 19.6, which gives us 0.255. Therefore, the answer is C.